Hello, I'm Scott Fryer, and today I'm going to talk about the use of Nagios to monitor the Adoptium infrastructure. The Adoptium project has a significant amount of servers and infrastructure. It covers many different operating systems, many different architectures, and they're used for a multitude of purposes, from building JDKs, running the automated tests, inventory management with Ansible, Jenkins CI/CD, and so on. So we have a requirement to monitor this infrastructure to try and proactively prevent any issues that arise as a result of things going wrong. So this is the Nagios server program. This is the landing page, so once you've logged in, this is the first thing you see. Now, the way Nagios works is it has a set of configuration files which define the hosts it should be monitoring and the services that it should be checking on those hosts to make sure they're in a good state. All of this is customizable, and you can extend it with additional plugins. There's a fairly extensive plugin exchange, and you can write your own to expand the functionality, which we'll cover a little bit later in the video. To get Nagios set up to monitor things, there's two elements: the Nagios server itself, and then usually some software to be installed on the hosts that are to be monitored. In the case of Unix-like systems, there are a couple of methods to monitor them, but the kind of most common one is via SSH connections. And for Windows hosts, again, if you can set up an SSH connection, you can monitor the system by SSH, or there's several agent-based plugins. The Adoptium project uses NTP for our Windows host at the moment, and that seems to work okay. The Nagios documentation offers lots of information about how to set those up. And again, within our Ansible playbooks, which are available in GitHub, you'll see there are several tasks and roles to install the requirements for the Nagios system onto the target hosts as part of those playbooks. So the first page we'll move on to look at is a quick overview of all the hosts we're monitoring. So in the left-hand menu, the hosts gives you a single list of all the hosts that are currently being monitored by Nagios, and there's some useful status things at the top which give you an idea of how many warnings, critical problems, how many hosts are down, and that's a really useful quick view for the health of your infrastructure. As you can see from our naming conventions, all this is defined within GitHub and the infrastructure repository in particular. You'll notice we have a naming scheme where the first element of a name is effectively its function. So we have a Jenkins server, a TRSSO, which is our test results service server, and then here all of the build machines, the Docker and Docker host machines that we use, and then the test machines. So that covers the function. The second element of our host naming convention is to have the provider name. So we have some Azure machines, some AWS machines, some IBM Cloud, Mac Stadium, Marist University. So that gives us our second stanza of our host name definitions. And the third and final element is a combination of the operating system and the hardware architecture it's based on. So again, we have an Ubuntu 20 on ARM v8, an Ubuntu 20 on x64, we have a Windows 2016 and 2019 x64, and so on. This allows us to define various elements of the monitoring solution. So moving on to the first of the three critical areas of the Nagios server. The first view that is incredibly useful is the host groups. This groups the infrastructure by the provider. Again, you see these are broken down by the infrastructure provider name, which forms the second element of the host name that's defined in our Ansible inventory. So this lets you view things from providers. So for example, if one provider had completely gone down for any reason, you would be able to see all the machines impacted. So this is the first really useful view. So moving on to the second thing, the second way of grouping within Nagios is the service groups. Now, within the current infrastructure setup, we only really monitor two types of service groups. So our Docker hosts, which are responsible for a wide variety of stuff, are monitored as a quick service group view, so you can see the state of all the Docker hosts, and the really critical infrastructure hosts, so our Jenkins, Nagios, and TRSS servers are also there to provide a quick view of the really critical infrastructure. The third and final view is the service problems, and this is probably from a maintaining infrastructure point of view the most important and most useful one, because it lists all of your hosts with warnings and critical errors that should be fixed. So a quick view of this page today shows that there's some disk space issues. There's a few operating systems that are requiring updates. CPU load one on this Windows machine, for example, is presumably because that machine is in the middle of a build. So again, sooner or later this will ease up. And you can see here we've actually got one machine that's currently offline, perhaps for maintenance. So we're probably going to check that with the provider and try and get it returned to service. Moving on, let's take a look at one of the problem hosts and work through fixing a problem. So let's let's have a look at one of the test systems that's got a critical warning on. So this Ubuntu host, if we click here, we'll get an overview of the general state. There's some links there to view the alert history and trends. But the kind of most useful page from a problem solving and managing issues is this view status deal for host. So this gives you an overview of the specific host we're looking at. The number of critical issues summary at the top again is quite useful, and you can see here the services that are being checked. So we've got ensuring that the NTP service is working properly and the network time is synchronized, which is important. We check if there's a Jenkins agent online within Jenkins for this host, and that's showing okay. CPU load, the amount of disk space on the root partition, ping and RAM check, free memory checks, all showing green. All of these checks are customizable on a per host basis, and you can adjust the thresholds to suit. It's all done in the configuration files on the Nagios server itself. There's a configuration file for each server, and again those checks can be extended and customized to suit whatever needs you like. But you can see here this particular server has an issue with it. It's got 15 packages that need upgrades, and 13 of them are critical updates, so presumably security updates from Ubuntu. The process now would be to either log an issue in the infrastructure repository and wait for somebody to fix it. So I'll pop away and do that. So the updates have been performed on the test host. So if we wait 5 minutes or so, the check will probably rerun and will clear, but we can manually reforce the check by clicking on the particular service and just rescheduling the next check of the service, which bumps it up the queue. Now if we wait a minute or two, if we go back to the status deal for this host, wait a minute or two for the page to refresh and the check to run. There's a very handy scheduling queue there, which there you go, it's showed up as fixed. There are no packages needing upgrade, and if we go back to the service problems, there's one less critical issue to take care of. So that covers identifying services that are problematic. I've quickly fixed one and shown how it updates. The other thing worth mentioning is you can configure how the Nagios server notifies. So it has the concept of administrators, user groups, all of these definable within the config, and even the notification mechanism. So you can notify via email, or as we do within Adoptium, we have a Slack channel configured with an API, the infrastructure bot, and Nagios will post whenever there's a new warning, or even when a problem has been solved, it will update and a message will be posted to the Slack channel. I think that covers everything for today. So thank you.